Algebra Lesson 11, Rational Expressions Canceling Factors. We have worked with factoring expressions before. We have factored expressions before, something like this one. Here where we would put parentheses, two sets of parentheses, what number can be multiplied to get 3, and what those two numbers, can they be added or subtracted to get this middle number? Well, that's what we'll be doing today, just simplifying with that as well. So let's get started with the number 1. I will go through all 6 of them with you today. So number 1, this one's more of a simple one, and to give you a note right away that all 6 of these are different. There may be here and there a few of them, a little step that's the same. The canceling part is the same, but how to factor them first, to split them apart, is what could be different in each one of these. So this one we do not need to split apart. It's just 8. 3 goes into 18 how many times? 6. Cross out once. So how many x's do we have in common? We have one x in common. So change that to an x squared. How many y's do we have in common? We have 2. So this completely crosses out. And then we have 2 left over here. So what we have left at the top is a 6x squared. What do we have left at the bottom? Just a y squared. And this would be your answer. Now we have simplified it as far as possible. Going on to the next one, this one has been factored for you. You don't need to first split this part apart. So how do we do this? Can we simplify anything out? Just leave the parentheses alone for now. Now, is there anything that we can simplify here? Well, we have one x in common, so that x gets crossed out. This 3 turns into a squared. So that part's done. Now with these parentheses, do we have anything in common? And what is in parentheses stays in parentheses. You cannot take this x and cross that x out. If this parenthesis is the same thing as this one, then we can cross both of them out, which it is. So let's cross these 2 out. Now what do we have left? This is as far as we can simplify. Now we have a 2 left at the top, and this x plus 9. What do we have left at the bottom? Just our x squared. And this is as far as we can simplify this. What is in parentheses, again, stays in parentheses. Now going on to the next one. This is what we use for the bottom part, not for the top. Now, first find the GC, greatest common factor in there, and then split it apart. So, I hope my head's not in the way. 3, can 3 go into both of these numbers? Yes. So we have 3 that's in common. It's the largest number that they both have in common. What about x's? How many x's do we have in common? We have 2 x's here. And we also have 2, but there's 3 here, but there's not 3 here. So let's take this x squared. Now what do we have left to get this? So we have 1 x left. So we put that here. And here we have 3 times what equals 9, which is 3. And we have no x's left. So that's it. That's for the top. Now for the bottom, we do the factoring. So find the square root of this, which is x. And now, what 2 numbers can we multiply to get 3 and add or subtract to get 1? No, to get 4. So possibly 3 and 1. And since they're both positives, they will both be positives here. Now, can we simplify this now? This looks more like that one now. So now we can simplify. This part and this part are the same. And is there anything else that we can simplify? No. So therefore, we have 3x squared over x plus 1. And that would be our answer for that one. So you probably see the similarities in all three of these, where you simplify and then that's as far as you go. That's really what we're doing. We're simplifying these expressions. Let's go on to number 4 to 6. So for number 4, we need to start factoring both of them, just as we did on number 3. I enjoy these. So here we go. X's. Anyway, we're going to do one at a time. What two numbers can we multiply to get 9 and add and subtract to get 6? Very likely just 3. And since they're both positive, you can make them both positive here as well. So 3 times 3 is 9, and 3 plus 3 is 6. Good. Now the bottom part. What two numbers can we multiply to get negative 21 and add or subtract to get negative 4? 21 would be 7 and 3. Let's try that. 7 and 3. Now, which one needs to be negative in order for it to become negative 4? The largest one. So, positive 3, negative 7. So now we go on and simplify. That's the main part of this lesson. So, these two are alike. Your answer is this. X plus 3 over x minus 7. Now, going on to this one. We did one of these in number 3, and we need to do that with both of them, since there's numbers that are in common in both of them. So here is 4 can go into both numbers, so 4. And then what do we have left? We have an x left here, and we have 2 left here, so 4 times. If you did distributive property, you should be able to get this. Now, the bottom one, we only have an x in common in both of these terms. So x, we have one x left here, and we have a 2 left here. We now have two things that are in common, and then cross out, and now that equals 4 over x. Quite simple there. Now the very last one, let's try to simplify this one as well. And this, you do the exact same way as that one. Now I wrote this one wrong. It's not 2x, it's x squared minus 4. The top, you do like we did there. And this bottom one, we factor again because it's a negative, and both of these are perfect squares. So what number goes into both of these? It's 3. We have an x and a 2 left over. And now, one of these will be a positive, one a negative. X square root of this, square root of this, which is 2 and 2. These two are similar, and your answer is 3 over x minus 2. Quite a lot of variety here. But once you understand that you can do there's so many different ways to do these, they actually get quite challenging and interesting. So do the last part of the lesson, the last few, number 35 to 37, right away. That way you can try on your own and then finish the rest of the lesson on your own.